Most of us think we understand the solar system. We've seen the diagrams in our school textbooks. We've watched countless animations online. We can even recite the names of the planets in order: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. It all feels so familiar, so close. But this entire understanding is built on a carefully constructed illusion. You see, almost every image of the solar system you've ever laid eyes on is deeply misleading. Not because the information is wrong, but because it simply can't be right. There is no possible way to show the true scale of space on a single page, a computer screen, or even a giant poster without breaking the very limits of human perception. The sizes of planets are wildly exaggerated. The vast, empty gaps between them are completely erased. This approach makes learning the basics much easier, but it quietly warps how we imagine our cosmic reality. The truth is, space is not crowded. It's not a busy celestial highway. It is not full of anything. Space is, for the most part, nothing. When we talk about the space between planets, it's not like an empty room or a hallway. It's an emptiness on a scale that our minds are not designed to comprehend. We're talking about vast, unimaginable distances where absolutely nothing happens, where a beam of light, the fastest thing in the universe, travels for minutes, hours, and even days without touching a single thing. When you look at a diagram with all the planets lined up side by side, your brain instinctively assumes closeness. It assumes there's a relationship, a neighborhood feel. It assumes that traveling from one to the next would be a relatively quick journey. But these assumptions completely shatter the moment you introduce real distances. Let's just consider Earth and our own moon. In most pictures, the moon floats right beside Earth, looking like you could almost reach out and touch it. And Neptune, the gap between the Earth and the moon, and you'd still have some room to spare. Our daily experience happens in meters and minutes. Even the fastest airplanes and the highest satellites move within scales that still feel somewhat human. Space does not. When we dream of space travel, we imagine constant movement. We see rockets firing. We feel speed. We crave action. But the true experience of traveling through space would be one of incredible stillness. It would be long, long stretches of time where absolutely nothing appears to change, where the stars in the distance barely seem to shift their position, where time itself seems to stretch out right alongside the distance you're covering. This is exactly why the true scale of the solar system feels so unreal when it's shown accurately. If you represent the distances honestly, the planets themselves disappear. They become microscopic, invisible dots separated by vast, overwhelming black gaps. To fit everything onto a single screen, something has to be sacrificed. And the thing that always gets sacrificed is the emptiness. But the emptiness is the main character in the story of space. It's the defining feature. The sun dominates our solar system, not just because it's large, but because it's one of the very few things that exists at all in this immense volume. Its gravity reaches out across these enormous distances to hold the planets in their orbits. Its light fills a space that would otherwise be completely, totally dark. But even the sun is small compared to the distances it controls. Let's try another thought experiment. If the sun were reduced to the size of a single grain of sand, our Earth wouldn't be right next to it. It would be a microscopic speck nearly a meter away. Jupiter would be over 5 meters away. Neptune would be 30 meters away. Imagine that, a single grain of sand holding a speck in orbit from 30 meters out. And beyond Neptune, the solar system doesn't just stop. It doesn't hit a wall. It simply becomes quieter, more sparse. The Kuiper Belt begins, a scattered ring of icy bodies like Pluto. Then, much farther out, is the Oort cloud, a vast spherical shell of comets and debris that extends far, far beyond the planets. These regions aren't crowded either. The objects within them are separated by distances so large that collisions are incredibly rare, happening on timescales longer than human civilization has even existed. The edge of our solar system isn't a boundary line. It's a slow fade to black. It's a gradual thinning of objects until the space around you becomes indistinguishable from the vast interstellar darkness between the stars. When we compress all of this into our neat little diagrams, we lose something vital. We lose the profound feeling of isolation. We lose the true sense that Earth is not surrounded by neighbors, but is instead surrounded by an almost infinite amount of distance. This illusion affects how we think about everything, from our place in the universe to the future of exploration. It makes space seem reachable, approachable, almost like a weekend destination. In truth, even reaching the outer planets of our own solar system with our current technology takes decades. Reaching the true edge of the solar system would take much longer than a single human lifetime. The Voyager spacecraft, two of the fastest objects ever created by humanity, have been traveling for more than 40 years, and they have only just barely begun to leave the sun's direct influence. Space does not yield its secrets easily. Understanding the true scale of the solar system isn't about memorizing numbers or distances. It's about fundamentally adjusting our intuition. It's about coming to terms with the fact that emptiness, not objects, is what defines our cosmic reality. The chaos of a crowded system is avoided because space gives everything and everyone enough distance to breathe. Before we head out into the wider solar system, let's take a moment right here, close to home. Not because Earth is special in its size, but because it's the only place where distance still feels almost understandable. Almost. The relationship between Earth and our moon is the closest large-scale cosmic connection most of us know. We see the moon all the time. It feels familiar, like a neighbor. It rises, it sets, it changes its shape throughout the month. It feels like a constant companion in our night sky. But even here, right on our cosmic doorstep, distance is already playing tricks on our intuition. The average distance between the Earth and the Moon is about 384,000 kilometers. That number sounds big, but numbers by themselves don't really tell the story. What truly matters is what's in between those two worlds, and the answer is pretty much nothing. If you could fly in a perfectly straight line from here to the moon, you would spend almost the entire trip in empty space. There's no atmosphere, no clouds, no fields of floating debris, just a pure, silent vacuum. This gap is so big that even a radio signal, traveling at the speed of light, takes more than a second to cross it. Think about that. The astronauts who walked on the moon were already separated from every other human by a noticeable delay. If they needed help, rescue was never going to be immediate. And yet, in the grand scheme of the universe, this distance is tiny. What makes it feel so huge to us is that it sits right at the very edge of human-scale experience. It's far enough to feel unreachable for most of us, but just close enough to remain a visible, tangible presence in our lives. This strange combination fools our brains. You've seen the diagrams in textbooks, right? Earth and the moon are drawn so close they're almost touching, with just a thin line separating them. But if you were to draw that to a true scale, you'd have a very different picture. On a single page, both the Earth and the moon would shrink to tiny dots, almost invisible. The vast, empty space between them would completely dominate the image. When we talk about the solar system, we usually picture the sun, right at the center. A glowing sphere with everything else revolving around it. And that's not wrong, but it's an incomplete picture. The sun isn't just a bright object holding planets in their tracks. It's a deep well in the fabric of space, shaping motion, time, and the very structure of our cosmic neighborhood in ways that go far beyond what we can see. Let's start with mass. The sun contains more than 99% of all the mass in the entire solar system. Think about that for a second. Every planet, every moon, every asteroid, and every single grain of dust, all combined, still weigh less than the sun alone. It's an imbalance that's hard to wrap our heads around because our instincts are built for Earth, where mass is spread out more evenly. But out in space, mass is king. It dominates everything. And the sun's gravity doesn't pull on things like a rope. It literally bends the fabric of space itself. Planets aren't circling because they're tethered. They're following curved paths through a warped region of spacetime created by the sun's immense presence. Without the sun, there would be no stable orbits, no planetary paths, no familiar structure at all. The sun isn't just at the center. It's the very reason a center exists. But even with this dominance, distance plays a crucial role. The sun is enormous compared to Earth, but the space between us is vast. It takes light about 8 minutes to travel from the sun to us. This means every sunrise you've ever seen is already 8 minutes old. If the sun were to suddenly vanish, we would continue orbiting nothing for 8 full minutes before darkness swept over us. There's no drama in this delay. It's quiet, constant, and a reminder of the scale we're dealing with. By solar system standards, Earth is close to the sun, but that closeness is still filled with an emptiness that defies our everyday understanding. Between us and the sun, there's almost nothing. No air, no particles dense enough to slow things down, just the occasional atom drifting through a near-perfect vacuum. To put it in perspective, if you shrank the sun down to the size of a basketball and placed it in the middle of a major city, Earth would be a tiny grain of sand orbiting several kilometers away. Most of the space between them would be empty streets, open air, and silence. And remember, this is just the inner solar system. The sun's influence stretches far beyond what we can see. A constant stream of charged particles, known as the solar wind, flows outward in all directions. This wind creates a colossal bubble called the heliosphere, which encloses all the planets and extends way past Neptune. The heliosphere is the boundary where the sun's influence starts to give way to the pressure of interstellar space. Even out there, far beyond where sunlight fades to black, the sun is still shaping the environment. But despite its commanding presence, the sun itself isn't perfectly still. It actually wobbles. The sun is constantly being tugged around a shifting center of mass. It's a subtle dance, but it reminds us of a fundamental truth. In space, nothing is truly stationary. Even the most massive objects respond to the pull of others. The sun also holds a quiet contradiction. To us, it feels eternal, unchanging, a constant source of light and life. But it's temporary. The sun is a middle-aged star, steadily burning hydrogen in its core. It's been doing this for billions of years and will continue for billions more. Yet, with every passing second, the sun loses mass. It converts matter into light and energy that radiates outward. It's slowly fading, even as it shines. This loss is minuscule in human terms, but over cosmic timescales it adds up. As the sun's mass decreases, its gravitational pull weakens ever so slightly. Planetary orbits expand just a little. Space is slowly, patiently reconfiguring itself. Change in the cosmos is rarely sudden. It's gradual, patient, and completely inevitable. The sun's light defines the character of the inner solar system. Mercury, Venus, Earth, and Mars all exist within a narrow band where the energy levels allow for solid surfaces and stable motion. Outside this region, conditions change dramatically. Mercury, being the closest, endures extreme temperature swings because it has almost no atmosphere to distribute the heat. Venus is trapped beneath a crushing greenhouse effect, making it the hottest planet. Earth is in that Goldilocks zone, where we balance energy just right. And Mars, a bit farther out, struggles to hold on to its warmth. These differences aren't random. They are direct consequences of distance from the sun. Distance dictates temperature, atmosphere, chemistry, and the potential for life. Even small changes in distance create enormous differences in outcome. That's why those neat diagrams showing planets evenly spaced are so misleading. They hide the steep, dramatic changes that occur between one orbit and the next. The sun's gravity even controls time itself in a subtle way. According to Einstein's theory of relativity, time passes slightly slower near massive objects. This effect, called gravitational time dilation, is tiny on a solar system scale, but it's real and measurable. Time itself bends toward mass. The sun's presence also defines what isn't there. Beyond its gravitational reach, objects are no longer bound to it. Interstellar space begins where the sun's gravity can no longer hold onto matter and stop it from drifting away into the cosmic void. This boundary isn't a sharp line. It's a fuzzy, layered, transitional zone. And the light we see from the sun carries its history. When we look at sunlight, we're not seeing the sun as it is right now. We're seeing its surface as it was 8 minutes ago. But the energy that creates that light began its journey long, long before that. It can take tens of thousands of years for energy generated in the sun's core to make its way to the surface before it finally escapes as a photon of light. The sunlight warming your face today started its journey long before modern human civilization even existed. This reframes our entire perception of the sun. It's not just a glowing ball. It's a slow, ancient machine operating on timescales that are far beyond human experience. The sun's ultimate fate is already sealed. In several billion years, it will run out of hydrogen fuel in its core. It will then expand into a red giant, swelling up and engulfing the inner planets. Earth will either be consumed or scorched into an uninhabitable cinder. After that, the sun will shed its outer layers, creating a beautiful planetary nebula, and its core will collapse into a tiny, dense white dwarf, a stellar remnant that will slowly cool over trillions of years. But that's a story for the distant future, far beyond any of our immediate concerns. For now, the sun remains stable, predictable, reliable, and yet its calm surface hides incredible power. Solar flares, coronal mass ejections, and magnetic storms can erupt from its surface, sometimes sending waves of energy and particles hurtling toward Earth. These events are a powerful reminder that even the most stable systems can have unpredictable outbursts. Space is never truly quiet. To truly understand the sun, we have to let go of our human-centric scales. It isn't a friend or an enemy. It is a structure, a force, a presence that shapes everything around it. As we prepare to journey farther out, the sun's light will weaken, its warmth will fade, but its influence will remain, shaping our path into the great unknown. Our next stop takes us beyond the rocky inner worlds, toward the realm where gravity still reigns, but sunlight becomes a precious, distant memory. Thanks for watching. If you found this journey illuminating, don't forget to like this video and subscribe for more deep dives into the cosmos. See you next time. Crossing the inner worlds, and where familiar space begins to end. Once we move beyond Earth, space begins to change in a subtle but important way. The inner solar system still feels structured, still feels organized, still feels almost familiar. Distances are large, but not yet overwhelming. Light remains strong. The sun still dominates the sky. Motion still feels connected. But familiarity is already fading. The inner planets Mercury, Venus, Earth, and Mars occupy a surprisingly small region when compared to the full size of the solar system. They are clustered close to the sun, packed into what feels like a tight neighborhood only because everything beyond them is so vast. Mercury is the closest to the sun, locked into an orbit where sunlight burns intensely. Days are scorching, nights are freezing. There is almost no atmosphere to soften extremes. Mercury exists in a state of exposure, directly shaped by distance and proximity. Venus follows, similar in size to Earth, but radically different in outcome. Thick clouds trap heat, surface temperatures soar, pressure crushes. A slight shift in distance and atmospheric chemistry transforms a world into something hostile and unrecognizable. Earth sits in a narrow band where energy balances just enough for stability. Not because Earth is special, but because conditions happened to align. Distance allowed moderation. Atmosphere regulated heat. Water persisted. Mars lies farther out, smaller, colder, thinner atmosphere. Evidence suggests it once held liquid water, but distance gradually changed its fate. The sun's warmth weakened. Gravity struggled to hold gases. Mars slowly dried and cooled. These worlds demonstrate a pattern. Distance defines destiny. Even small changes in orbital distance create dramatic differences over time. The inner solar system is not a smooth gradient. It is a series of thresholds where conditions shift suddenly from one regime to another. Between these planets, space remains mostly empty. There are no highways, no invisible paths, just enormous regions where nothing happens. Travel between inner planets is not difficult because of obstacles. It is difficult because of scale. Spacecraft do not move through busy environments. They drift through emptiness, guided by gravity and momentum, adjusting course with brief engine burns, separated by months or years of silence. This silence grows as we move outward. Beyond Mars, the inner solar system begins to thin. The asteroid belt appears next, often imagined as a crowded field of tumbling rocks. This is another illusion. In reality, asteroids are separated by vast distances. Collisions are rare. A spacecraft could pass through the asteroid belt without encountering anything at all. The belt is a population, not a barrier. The asteroid belt marks a transition zone. It is where planetary formation was disrupted, largely by the influence of Jupiter's gravity. Matter that might have formed a planet instead remained scattered. Here, the sun's light is noticeably weaker. Solar panels produce less energy. Temperatures drop. Space feels colder, not because cold exists, but because heat is rarer. Crossing this region changes perception. The inner planets feel behind you. The sun becomes smaller. The sense of being anchored begins to loosen. The solar system is still orderly, but its order stretches. From this point outward, distances grow faster than intuition expects. Each orbit is not just slightly farther than the last, it is dramatically farther. The gap between Mars and Jupiter alone is larger than the combined distances between several inner planets. This pattern continues outward, expanding scale rapidly. This is where diagrams fail most completely. They compress these gaps until everything appears evenly spaced. In reality, the solar system opens up suddenly, like stepping out of a narrow hallway into a vast, empty plain. The sun's influence remains strong, but its presence fades visually. It becomes a bright star, rather than a dominating disk. Shadows soften. Space darkens. Time begins to stretch. Light delays increase. Communication slows. Decisions must be made far in advance. Spacecraft operate autonomously for long periods, guided by pre-planned instructions rather than real-time control. This autonomy reflects the nature of space itself. Distance removes immediacy. In the inner solar system, sunlight still defines day and night clearly. Farther out, cycles blur. Days lengthen. Seasons stretch. Time feels less segmented. The inner solar system feels alive because change is visible. Clouds move. Planets rotate quickly. Sunlight shifts noticeably. As we move outward, change slows. Motion continues, but it becomes subtle. Everything still moves, but nothing announces it loudly. This quiet is not absence, it is scale. The inner solar system represents the last region where human intuition retains some grip. Beyond this point, space stops feeling like an extension of familiar experience and starts feeling abstract, not because it is unknowable, but because it operates on scales that remove urgency. Understanding this transition is important. It teaches that space does not suddenly become strange. It becomes distant gradually, layer by layer, orbit by orbit. By the time we reach the outer planets, the sun will no longer feel like a center. It will feel like a memory. The inner worlds are defined by warmth, light, and rapid motion. They are shaped by proximity. They respond quickly to changes. They feel dynamic. The outer regions are defined by patience. Nothing in space is rushed. But beyond the inner system, time itself seems to slow, not because it actually does, but because events unfold across longer intervals. This change in pacing prepares us for what comes next. Entering the realm of giants, and where scale loses meaning as we continue outward, the solar system undergoes a dramatic transformation. Until now, planets have felt solid, defined, grounded, rock, metal, surface, terrain. Worlds you could imagine standing on. Worlds shaped by impacts, erosion, atmosphere, and time. But ahead lies a completely different category of object. The gas giants. Jupiter appears first, and nothing in the inner solar system prepares you for its presence. Size stops being intuitive. Comparison becomes meaningless. Jupiter is not simply larger than Earth. It exists on an entirely different scale of mass and gravity. If Earth were reduced to the size of a grape, Jupiter would be a large beach ball nearby. But even that analogy fails to capture the truth. Jupiter is more massive than all the other planets combined. Its gravity dominates the outer solar system, shaping orbits, capturing moons, bending trajectories. Approaching Jupiter feels less like visiting a planet and more like entering a gravitational system of its own. There is no surface in the familiar sense, no ground, no place to stand. What exists instead is depth, layer upon layer of atmosphere compressing into exotic states of matter. Hydrogen becomes metallic, pressure rises beyond comprehension. Lightning flashes across cloud tops larger than entire planets. The famous Great Red Spot is not a storm in the way we understand storms. It is a structure, a centuries-old vortex, wider than Earth itself, sustained by energies far beyond terrestrial weather. Time behaves differently here, not because physics changes, but because scale changes perception. A storm lasting hundreds of years no longer feels temporary. It feels permanent. Jupiter's moons orbit within this immense gravitational field, like a miniature solar system. Io burns with volcanic fury. Europa hides an ocean beneath ice. Ganymede is larger than Mercury. Listo is ancient and scarred. Each moon is a world, shaped not just by its own gravity, but by Jupiter's relentless pull. Tidal forces knead interiors, generate heat, and drive geological activity far from the sun's warmth. Jupiter teaches a critical lesson. Heat does not only come from stars. Gravity itself can be an energy source. Beyond Jupiter lies Saturn, quieter but no less profound. Its rings dominate perception, yet they are thin, fragile, temporary on cosmic timescales. Saturn is less dense than Jupiter, composed mostly of hydrogen and helium, but its beauty is deceptive. Saturn's gravity sculpts its moons with precision. Enceladus sprays water vapor into space. Titan holds lakes of liquid methane beneath the hazy sky. These moons exist in balance between cold distance and gravitational warmth. The gas giants redefine what a planet can be. They are not failed stars. They are not oversized Earths. They are something else entirely. Massive envelopes of gas held together by gravity, with no clear boundary between atmosphere and interior. As we move through this region, sunlight fades noticeably. Solar energy weakens. The sun shrinks into a bright point rather than a disk. Shadows soften. Contrast decreases. Space grows dimmer. Communication delays lengthen. A signal from Earth takes over an hour to reach Jupiter. Decisions made here must account for isolation. Spacecraft become explorers rather than remote tools. Past Saturn, Uranus, and Neptune await. Ice giants, different from their gas giant cousins. Smaller, colder, richer in water, ammonia, and methane. Their atmospheres glow blue from absorbed light. Winds scream at supersonic speeds. Axial tilts defy expectation. Uranus lies on its side, seasons lasting decades. Neptune radiates more heat than it receives, powered by internal energy still not fully understood. These planets feel distant, not only in space, but in comprehension. Here, the solar system no longer feels centered on the sun. Gravity belongs to planets. Motion feels distributed. The sun becomes one influence among many. Beyond Neptune, planetary order dissolves into populations. The Kuiper Belt spreads outward, filled with icy remnants and dwarf planets. Pluto drifts here, complex and active despite its distance. Eris follows a lonely path far beyond. Objects move slowly. Orbits take centuries. Light is faint, cold, dominates. This region feels less like a system and more like a boundary, a transition between structure and dispersion. The gas giants mark the last region where planetary gravity creates dominant hubs. Beyond them, everything becomes sparse, scattered, patient. Distance now erases immediacy completely. Even light feels delayed. The solar system stretches into abstraction, and yet, even here, gravity still binds. The sun's influence extends far beyond what vision suggests. It holds comets in distant reservoirs, shaping trajectories over millions of years. The lesson deepens. The universe does not end suddenly. It thins, it stretches, it quiets. The edge of the solar system and the slow fade of influence beyond the final planets, the solar system begins to feel less like a place and more like a memory. Motion slows, structure loosens, distances stretch so far that even familiar concepts like orbit and direction lose their emotional meaning. Here, the sun no longer dominates the sky. It becomes a distant star among countless others, still powerful, still influential, but no longer overwhelming. This region is not empty, it is quiet. There is a difference. The Kuiper Belt spreads outward like a faint halo of frozen remnants. Trillions of objects drift here, leftovers from planetary formation, untouched for billions of years. They are small, dark, cold, and patient. Each one carries the chemistry of the early solar system, preserved in deep freeze. Pluto lives here, but it is not alone. Eris, Haumea, Makemake, Sedna, and countless unnamed bodies share this space. These are not failed planets, they are survivors. Records of a time when the solar system was still chaotic, still colliding, still sorting itself into order. Sunlight here is weak, barely enough to warm surfaces above absolute darkness. A year on Pluto lasts 248 Earth years. Seasons unfold so slowly they resemble geological processes rather than weather. Ice behaves like rock. Rock behaves like ice. Communication from Earth becomes abstract. A radio signal takes more than 4 hours to reach Pluto. Commands sent now will be answered later, long after the context has changed. Spacecraft must think ahead, anticipate conditions, and operate independently. Human presence feels conceptually distant. Beyond the Kuiper Belt lies something even more elusive. The scattered disk. Objects here follow elongated, tilted orbits stretching far beyond Neptune's influence. Their paths are reminders that gravity does not enforce order, it negotiates. Some of these bodies travel thousands of astronomical units from the Sun before slowly returning inward. Their journeys take tens of thousands of years. They move not through space, but through epochs. Then comes the hypothesized boundary, the heliopause. This is not a wall, it is a region. A gradual fading where the solar wind, the constant stream of charged particles from the Sun, slows and finally yields to the interstellar medium. Here, the Sun's breath ends. The heliosphere is the bubble carved by our star as it moves through the galaxy. It shields the solar system from much of the high-energy cosmic radiation beyond. It defines where the Sun's influence truly stops. Voyager 1 crossed this boundary in 2012. Voyager 2 followed years later. Their instruments detected changes not through sight, but through particles and fields. A drop in solar particles, a rise in galactic ones. There was no dramatic visual transition, no line crossed, just a quiet shift in dominance. Beyond this point, the Sun is no longer the primary sculptor. The galaxy takes over. The interstellar medium is thin beyond comprehension. A few atoms per cubic centimeter. Yet over vast distances, it shapes stars, feeds nebulae, and participates in the slow recycling of matter. This is where stellar systems exchange material, where remnants from one star's formation become seeds for another. Somewhere far beyond the heliopause may exist the Oort cloud, a vast spherical shell of icy bodies extending tens of thousands of astronomical units outward. Its existence is inferred, not observed directly. It is a mathematical necessity, not a visual one. The Oort cloud is the source of long-period comets, objects disturbed by passing stars or galactic tides sent plunging inward toward the sun after spending billions of years in darkness. These comets are time travelers, messengers from the edge. At these distances, gravity is gentle but persistent. The sun's pull weakens but never truly vanishes. It becomes a suggestion rather than a command. Passing stars influence this region. A star drifting close millions of years ago may have reshaped the Oort cloud, altering trajectories that will only reveal themselves far in the future. The solar system is not isolated. It participates in galactic motion, subtly interacting with its neighbors. Here, the idea of ownership dissolves. Objects are not fully bound to the sun, nor fully free. They exist in transition. The concept of edge becomes meaningless. There is no clear boundary where the solar system ends and interstellar space begins. There is only influence fading into irrelevance. Light from the sun is now indistinguishable from light from other stars. The sky becomes a dense field of points, not dominated by any single source. Orientation loses meaning, up and down vanish. Only distance remains. At this scale, time stretches differently. Events unfold over millions of years. Human lifespans vanish into statistical noise. Even civilizations become brief phenomena. This is where the solar system stops feeling personal. Yet this region is crucial. It is where stability gives way to exchange, where matter leaves and arrives, where the solar system interacts with the broader galaxy. Every atom in your body once passed through regions like this, between stars, between systems, between eras. The boundary between solar systems is not a barrier, it is a corridor. The quiet here is not emptiness, it is anticipation. Drifting between stars and the true meaning of distance. Now we are no longer inside the solar system. There is no central star commanding attention, no familiar gravitational hierarchy. We have crossed into interstellar space, a region defined not by objects, but by separation. The nearest star is still far away. Proxima Centauri, the closest stellar neighbor to our sun, lies more than 4 light-years from Earth. That distance is so vast that even light, the fastest thing in the universe, takes over 4 years to cross it. Every star you see in the night sky is separated from the next by distances that dwarf everything we have experienced so far. Interstellar space is not a place you arrive at. It is something you pass through endlessly. Here, stars are isolated islands of gravity, drifting through a dark ocean of near vacuum. The space between them is thin beyond comprehension, yet it holds structure. Hydrogen atoms wander, cosmic dust drifts slowly, magnetic fields stretch and twist over light years. Nothing moves quickly here, even stars feel slow. The sun itself travels through the Milky Way at roughly 220 kilometers per second. Yet, Compared to galactic scales, this motion feels gentle. The Sun completes one orbit around the galaxy every 225 to 250 million years. One galactic year equals the rise and fall of entire species. As we move farther from our home star, constellations begin to distort. The familiar shapes humans have named for thousands of years slowly dissolve. Orion stretches, the Big Dipper warps, perspective changes everything. Distance reshapes truth. Interstellar space teaches a quiet lesson. Most of the universe is not filled with things. It is filled with space between things. Matter is rare. Emptiness dominates. And yet, that emptiness is what allows structure to exist at all. Gas clouds slowly collapse here over millions of years, birthing new stars. Supernova remnants spread heavy elements across light years, enriching future systems. The space between stars is where recycling happens, where endings quietly become beginnings. Temperature approaches the cosmic background, just a few degrees above absolute zero. Heat is memory rather than presence. Sound cannot exist. There is no medium dense enough to carry it. Silence here is not poetic, it is physical. If you were somehow suspended in interstellar space, there would be no sensation of movement, no wind, no pressure, no reference frame. You would be falling and standing still at the same time. Navigation becomes conceptual rather than visual. Stars are points without size. Distances are measured in years rather than kilometers. Direction becomes relative. Even communication struggles. A message sent from Earth to Proxima Centauri would arrive long after the context of its creation had passed. Replies would belong to another era. Civilizations become isolated by physics itself. This is why interstellar travel remains a dream rather than a plan, not because we lack imagination, but because the universe enforces patience. Energy requirements explode. Time stretches beyond lifetimes. At this scale, survival depends on continuity rather than speed. The Milky Way reveals itself slowly as a flattened disk of stars, gas and dust stretching 100,000 light-years across. Spiral arms curve gracefully, shaped by density waves moving through the galactic disk. These arms are not solid structures. They are patterns, like traffic jams of stars temporarily sharing space. Our sun resides in a quiet region between arms, far from the galactic center. This is not accidental. Regions near the center are crowded, chaotic, bombarded by radiation and gravitational disturbances. Stability is rare there. Life benefits from distance. As we drift farther, the galactic center grows brighter. A dense glow formed by billions of stars packed tightly together. Hidden within that brightness lies a supermassive black hole. Sagittarius A*, quietly anchoring the galaxy with its gravity. It does not consume everything around it. It waits. Most stars in the galaxy orbit peacefully, never approaching the center closely. Chaos exists, but it is localized. Order dominates on average. Interstellar space reveals the balance between violence and calm. Supernova occur. Stars collide. Black holes merge. Yet vast regions remain undisturbed for billions of years. The galaxy is not hostile by default. It is indifferent. Stars form in clusters, live together briefly, then drift apart. The Sun was born in such a cluster. Its siblings are scattered across the Milky Way, indistinguishable now from other stars. Every stellar system is temporary. Gravity binds for a time, then releases. Orbits evolve, systems dissolve. Nothing lasts forever, but nothing ends abruptly either. Interstellar space is where patience rules. As we move farther still, individual stars blur into collective glow. The Milky Way becomes an object rather than an environment, a structure floating in darkness. Distances between galaxies become even more extreme. The nearest major galaxy, Andromeda, lies over 2.5 million light-years away. Light left Andromeda before modern humans existed. Between galaxies lies true emptiness, not absolute nothingness, but close enough that matter becomes statistical rather than tangible. Here, the universe becomes scale itself. Interstellar space teaches humility, not through threat, but through proportion. It shows how small structures are compared to separation, how rare matter truly is. And yet, within this vast emptiness, complexity arises, chemistry organizes, stars ignite, planets form, life emerges, not because the universe is crowded, but because it is spacious. The Milky Way as a single object, and the illusion of home as we continue outward, something subtle but profound begins to happen. The Milky Way stops feeling like a place you exist inside, and starts to feel like an object you are observing. What once surrounded you now sits before you, suspended in darkness, rotating slowly, silently, patiently. From this distance, individual stars no longer matter. They merge into a soft, luminous structure. Billions of suns collapse into a single form, a spiral disk stretching across space, edged with faint wisps of gas and dust. This is our galaxy, seen whole. The Milky Way is vast beyond instinct, roughly 100,000 light-years across, containing hundreds of billions of stars, possibly more. Most of them host planets. Many of those planets exist in environments we can barely imagine. And yet, from here, all of that complexity becomes a single shape. Spiral arms curve gently, not as rigid structures, but as flowing patterns. They are regions where stars are born more frequently, where gas clouds compress and ignite under gravity. These arms drift slowly around the galactic center, taking hundreds of millions of years to complete a single rotation. Our sun sits far from the center, roughly halfway out in one of the quieter regions, safely removed from the chaos closer in. This location is not dramatic, but it is forgiving. Radiation is lower, stellar density is thinner. Catastrophic events are rarer. Distance provides stability. At the heart of the Milky Way lies a dense bulge of stars, glowing intensely. Hidden within that glow is Sagittarius A*, a supermassive black hole with a mass of about 4 million suns. It does not dominate the galaxy visually, but gravitationally, it anchors everything. Despite popular imagination, this black hole is not a cosmic vacuum cleaner. It does not consume the galaxy. It waits, exerting influence only within its immediate neighborhood. Most stars orbit peacefully, never venturing close. Galaxies are not ruled by violence. They are governed by balance. From this perspective, the Milky Way appears serene, almost delicate. But this calm hides a long and turbulent history. Our galaxy formed over billions of years through mergers, collisions, and gradual accumulation. Smaller galaxies were absorbed. Star clusters were stretched into streams. Remnants of past encounters still linger as faint scars. The Milky Way is not a closed system. It is still growing. Even now, it is pulling in smaller satellite galaxies, including the large and small Magellanic Clouds. These companions orbit slowly, shedding stars and gas that feed the Milky Way's outer regions. In a few billion years, they will be fully absorbed. This is how galaxies evolve. Not suddenly, but patiently. Time behaves differently at this scale. Events unfold over hundreds of millions of years. Structures change slowly enough that no single moment feels significant. Meaning emerges only when viewed across vast spans. From here, the idea of home becomes fragile. Earth, once so central, is now invisible. The solar system is lost among billions of others. Our familiar sky exists only in memory. Yet this distance does not erase meaning. It reframes it. The Milky Way contains regions of extreme beauty and extreme danger. Star-forming nebulae glow with ionized gas. Supernova remnants expand like cosmic flowers. Black holes merge, sending ripples through space-time. And between these events lie enormous quiet zones where nothing dramatic happens for billions of years. Life requires those quiet zones. Too close to the center, radiation's too far out, heavy elements are scarce. Habitability exists only within a narrow band. The galactic habitable zone, our sun, happens to reside within it. That coincidence carries weight. From this distance, we see that galaxies themselves are rare islands. Most of the universe is empty. Vast voids stretch between clusters, containing almost nothing. Matter gathers only where gravity has slowly sculpted it. The Milky Way is one such gathering, a temporary arrangement of matter, held together for now. Galaxies are not permanent. Over time, they collide, merge, and transform. In about 4 billion years, the Milky Way will collide with Andromeda. The two spirals will interpenetrate, stars passing harmlessly by one another, gravity reshaping everything. The result will be a new galaxy, likely elliptical in shape, with a new identity. Nothing familiar survives unchanged. From here, we begin to understand that identity itself is scale-dependent. What feels solid up close dissolves into abstraction from afar. Home becomes coordinates. History becomes motion. The Milky Way is not special because it is ours. It is special because it is typical. A spiral galaxy among hundreds of billions. Each galaxy holds its own internal weather of stars and dust. Each follows its own trajectory through cosmic time. None are central. None are privileged. This realization is not diminishing. It is grounding. It tells us that complexity does not require uniqueness. Meaning does not require centrality. Life does not require attention. As we drift farther, galaxies begin to group together. Clusters form. Superclusters stretch across tens of millions of light years. Filaments connect these structures like threads in a vast cosmic web. The Milky Way is a single knot in that web. From here onward, we are no longer studying environments. We are studying architecture, the structure of the universe itself, the cosmic web and the skeleton of everything. As we pull back even farther, galaxies begin to lose their individuality. The Milky Way no longer stands alone as a graceful spiral. It becomes a single point of light among countless others, each one representing an entire galaxy filled with stars, planets, histories, and possibilities. What emerges next is not a collection of objects, but a pattern. The universe reveals its largest structure. Galaxies do not scatter randomly through space. They follow an invisible architecture shaped by gravity and time. On the largest scales, matter organizes itself into filaments, sheets, and clusters, forming what astronomers call the cosmic web. This web stretches across hundreds of millions of light years. It is the skeleton of the universe. Long, faint strands of galaxies trace paths through darkness, connecting dense clusters like threads between knots. Between these filaments lie vast voids, regions so empty that even galaxies are rare. These voids are not small. Some span tens of millions of light years, containing almost nothing at all. From here, emptiness becomes dominant. The cosmic web formed shortly after the Big Bang, when tiny fluctuations in density were amplified by gravity. Slightly denser regions pulled in more matter, growing denser still, while emptier regions lost matter and became voids. Over billions of years, this process sculpted the universe into its current form. Dark matter plays a crucial role here. Though invisible, it outweighs ordinary matter by a factor of 5. It provides the gravitational scaffolding upon which galaxies assemble. Where dark matter concentrates, galaxies follow. Where it thins, space empties. We cannot see dark matter directly, but we can see its influence everywhere. Galaxy clusters sit at the intersections of filaments, massive congregations containing hundreds or even thousands of galaxies bound together by gravity. These clusters glow faintly in X-rays, filled with hot gas, heated by immense gravitational forces. Time behaves differently here. Light from one side of a cluster may take millions of years to reach the other. Motions unfold slowly, measured not in years, but in epochs. Clusters are not static. They merge, grow, and evolve, drawing in galaxies along filaments like beads sliding along strings. Between clusters lie superclusters, even larger structures that defy easy definition. They are loosely bound, sprawling regions of enhanced density stretching across hundreds of millions of light years. Beyond that, structure fades. The cosmic web is not infinite. It has limits. On the largest scales, the universe becomes smooth again, homogeneous and isotropic. Patterns dissolve into statistical uniformity. This scale is where cosmology takes over from astronomy. From here, individual events no longer matter. Only averages remain. The universe is expanding. Space itself stretches, carrying galaxies apart. On small scales, gravity overcomes this expansion, binding galaxies into groups and clusters. But beyond those scales, expansion wins. The farther we look, the faster galaxies recede. Eventually, recession exceeds the speed of light. Not because galaxies move through space too fast, but because space itself expands between us. These galaxies are not breaking any rules. They are simply being carried away. This creates a horizon. There are regions of the universe we will never observe, no matter how long we wait. Their light will never reach us. They exist beyond our cosmic event horizon, forever inaccessible. The observable universe is not the whole universe. It is just the part whose light has had time to arrive. This realization reshapes meaning. Everything we have ever seen, measured, or imagined exists within a finite bubble. Beyond it lies more universe, likely similar, possibly infinite, but forever beyond contact. The cosmic web continues beyond our horizon, connecting structures we will never know. From this scale, the universe feels less like a place and more like a process. Matter flows, structures form and dissolve, Expansion accelerates. Dark energy dominates now. A mysterious force driving accelerated expansion, pushing galaxies apart faster over time. Its nature remains unknown. Its effects are undeniable. As dark energy grows more influential, the cosmic web will slowly tear itself apart. Clusters will drift away from one another. Filaments will thin. Voids will expand. In the distant future, each remaining galaxy cluster will become an island universe, isolated from all others by unbridgeable distance. Connection will end. This is not sudden. It unfolds over trillions of years, slowly, quietly, inevitably. The universe does not collapse into chaos. It fades into isolation. Looking at the cosmic web teaches a profound lesson. Structure arises naturally from simple rules. Complexity does not require intention. Order does not require design. Gravity shapes. Time amplifies. Expansion stretches. From this perspective, life appears fragile, but not accidental. It emerges where conditions allow, persists briefly, and vanishes, not as a failure, but as a phase. We are part of the web, not observers outside it. Every atom in your body once flowed through these filaments, forged in stars, scattered by explosions, gathered again by gravity. The cosmic web is not abstract. It is personal. The same forces shaping clusters shape cells, just at different scales. From here, the idea of center disappears completely. There is no privileged location, no absolute reference point. Every observer sees themselves at the center of their observable universe. This is not illusion, it is geometry. Meaning becomes local. As we approach the largest scales, questions shift. We stop asking where things are and start asking why conditions exist at all. Why the universe has this structure. Why these constants. Why expansion behaves this way. These questions do not have answers yet, and perhaps they never will. The observable universe and the quiet border of knowing, as we continue to pull back, structure itself begins to soften. The cosmic web fades from sharp filaments into faint statistical patterns. Clusters blur, voids expand. Eventually, even the largest architectures lose their definition. What remains is not emptiness, but uniformity. We have reached the scale where the universe stops being something we travel through and becomes something we measure. This is the observable universe. It is defined not by walls or edges, but by time. Light has a finite speed. The universe has a finite age. Because of this, there is a limit to how far we can see. Beyond that distance, light simply has not had enough time to reach us. Everything within this boundary is visible in principle. Everything beyond it is forever hidden. The observable universe is about 93 billion light-years across. That number feels impossible because it contradicts intuition. The universe is only 13.8 billion years old. How can it be larger than that? The answer lies in expansion. Space itself has been stretching since the beginning. As light travels, the space it moves through expands beneath it. Distances grow even as photons are in transit. The universe is not a static stage. It is an active participant. Looking farther away is not looking across space. It is looking back in time. Light from the most distant galaxies began its journey when the universe was young. Those galaxies no longer exist in the same form. Some have merged, some have evolved, some may have vanished entirely. We do not see them as they are. We see them as they were. The farther we look, the younger the universe appears. At extreme distances, galaxies lose shape. They become small, chaotic, intensely bright objects. Star formation was furious then. Matter was dense. Energy filled space. Order had not yet emerged. Beyond that lies the cosmic microwave background. This faint glow fills all of space. It is the aftermage of the early universe, released when matter cooled enough for light to travel freely. Before that moment, the universe was opaque. Photons were trapped, constantly scattered by charged particles. The cosmic microwave background is the oldest light we can see. It comes from a time when the universe was just 380,000 years old. In it, we see tiny fluctuations, slight differences in temperature. These variations are the seeds of all future structure. Every galaxy, star, planet, and person traces back to those fluctuations. Beyond this point, light does not exist in any meaningful way. The universe was too hot, too dense, too energetic. We cannot see further back because there is nothing to see. This is not a technological limitation, it is a physical one. The observable universe has a horizon, not an edge in space, but an edge in time. Beyond it lies reality without information. Even now, that horizon continues to change. As time passes, more light reaches us. We see slightly farther, but accelerated expansion complicates this picture. Dark energy drives space to expand faster over time. This means some regions that are currently visible will eventually disappear beyond our horizon. Their light will stretch, redden, and fade until it can no longer reach us. The observable universe is not fixed, it evolves. In the far future, distant galaxies will vanish from view. The night sky will grow darker. Only the local group of galaxies will remain visible, bound together by gravity. Astronomy will become harder. Evidence of expansion will fade. The cosmic microwave background will redshift beyond detectability. Future observers may never know the true scale of the universe. Knowledge itself has a lifespan. Standing at this boundary, questions become philosophical, not because science fails, but because it reaches its limits. We can describe how the universe behaves. We can measure its expansion. We can map its structure. But why these laws exist remains unanswered. Why does the universe expand at all? Why does dark energy exist? Why are physical constants tuned to allow complexity? These are not idle questions. They shape everything. Some propose multiple universes. Others suggest deeper laws, yet undiscovered. the future of the universe, and the slow dimming of everything now, we stop moving outward. Distance no longer matters. There is nowhere left to go. Instead, we turn forward in time, away from space, toward the future. And what the universe shows us next is not dramatic. It is quiet, slow, patient. The universe does not end with an explosion. It ends with a fade. Right now, stars still shine, galaxies still glow. New suns are born in nebulae. Heavy elements continue to circulate. Life, where it exists, still has warmth and energy to work with. But these conditions are temporary. Star formation is already declining. The universe was most active billions of years ago. Back then, galaxies formed stars at furious rates. Gas was plentiful. Collisions were common. Energy was abundant. Now, much of that gas has already been locked into stars or expelled into intergalactic space. Each generation of stars consumes more fuel, less remains for the next. Over the next trillions of years, this trend continues. Fewer stars are born. Existing stars age and die. Red dwarfs, small and efficient, outlive all others. They burn slowly, quietly, for trillions of years. Eventually, even they fade. Massive stars explode as supernova, leaving behind neutron stars and black holes. Medium stars, like our sun, swell into red giants, shed their outer layers, and collapse into white dwarfs. These white dwarfs glow faintly at first, then slowly cool. Given enough time, every star becomes dark. Galaxies change character. Spirals lose their bright arms. Ellipticals dim. Star clusters disperse. The night skies of any remaining planets grow increasingly empty. Energy becomes harder to find. Black holes grow as they consume nearby matter or merge with one another. In the distant future, black holes become the dominant massive objects in the universe. They outlast stars. They outlast galaxies. But even black holes are not eternal. According to our best understanding, black holes slowly lose mass through Hawking radiation. This process is incredibly slow for large black holes. A stellar mass black hole would take far longer than the current age of the universe to evaporate. Supermassive black holes take even longer, but given enough time, even they disappear. After unimaginable spans of time, measured in numbers with dozens of zeros, the universe enters a state known as heat death. Not because everything is hot, but because everything is cold and uniform. Energy differences disappear. Work becomes impossible. No engines can run. No processes can extract usable energy. Time still exists, but nothing meaningful happens. Atoms may still persist. Particles may still drift. But complexity ends. Before this final stillness, there may be intermediate eras. Protons may decay, breaking matter apart into radiation and lighter particles. Neutrinos may dominate. Physics itself may behave differently as energies approach minimum states. These ideas remain theoretical. We do not know for certain how matter behaves on such extreme timescales, but all paths lead to the same theme. The universe grows quieter. Expansion continues. Galaxies outside local groups vanish beyond horizons. Each remaining island universe becomes isolated, surrounded by darkness. Observers, if any exist, would see a vastly emptier cosmos, without evidence of expansion, without visible relics of the Big Bang. Knowledge of cosmic origins would fade. Memory itself becomes fragile. The universe does not collapse inward. It does not tear itself apart violently. It simply stretches until connections break. This future is not tragic, it is neutral. The universe does not value activity over stillness. It does not prefer life to silence. It follows its equations faithfully. And yet, something remarkable remains. This quiet ending is only possible because the universe once allowed complexity to emerge. Stars burned, galaxies formed, life arose, awareness appeared, questions were asked. The fact that we can contemplate this future at all is extraordinary. The universe produced observers capable of understanding its fate long before that fate arrives. Awareness is temporary but real. Time does not erase meaning retroactively. A sunset does not become meaningless because night follows. From this perspective, impermanence does not diminish existence, it defines it. Every structure that exists does so briefly, relative to eternity, that includes stars, galaxies, civilizations, and thoughts. Their value lies not in duration, but in occurrence. The future of the universe is vast, cold, and quiet, but the present is rich, dynamic, and alive. We exist in a narrow window between chaos and stillness, between birth and fade, between fire and ash. That window is rare. Why complexity exists at all, and the quiet permission of the universe, after imagining the long future of fading stars and cooling matter, a deeper question naturally rises. Not about when the universe ends, but about why it ever began to organize in the first place, why anything formed at all, why matter did not remain forever smooth and empty, why complexity was allowed to appear. The universe did not have to become interesting. In the earliest moments after the Big Bang, everything was simple. Energy was dense, particles moved freely. There were no atoms, no stars, no planets, just heat, expansion, and symmetry. In such a universe, nothing like life could exist, nothing persistent, nothing aware. And yet, tiny imperfections were present. Minuscule fluctuations in density, slight differences in energy. These imperfections were not planned, they were not designed. They simply existed. Gravity noticed them. Where matter was slightly denser, gravity pulled more strongly. Over time, those regions grew denser still. This is the quiet origin of all structure, not intention, not purpose, just amplification. Complexity begins with imbalance. If gravity were weaker, matter would never gather. If it were stronger, everything would collapse too quickly. If expansion were faster, structures would tear apart. If slower, everything would fall inward. The universe balances on a narrow edge between extremes. This balance is not stable in the human sense. It is dynamic, constantly adjusting, constantly changing. But it is permissive. The laws of physics do not create complexity, they allow it. Atoms form because electromagnetic forces bind electrons to nuclei. Chemistry exists because these bindings can rearrange. Molecules form shapes, shapes interact, systems emerge. None of this is guaranteed by logic alone. It depends on the values of fundamental constants. Change them slightly, and atoms dissolve. Stars fail to ignite. Chemistry collapses. The universe does not explain why these constants have their values. It simply operates with them. This raises an unsettling possibility. Perhaps many universes exist, each with different rules. Most remain empty, sterile, unstructured. A few, by chance, allow complexity. We exist in one of those few because we could not exist anywhere else. This idea does not require intention. It requires selection. Observers only appear where observation is possible. This is known as the anthropic principle. It is not an answer. It is a boundary. It tells us why we should not be surprised to find ourselves in a universe that allows life, but it does not explain why such universes exist at all. That question remains open. Complexity is fragile. It requires energy gradients, differences in temperature, differences in density, differences in time. As the universe ages, these differences fade. The future we explored earlier is quiet because complexity cannot survive uniformity. Life exists because the universe is young enough to still be uneven. Stars shine because nuclear reactions convert mass into energy. Planets remain warm because they orbit stars. Chemical reactions proceed because energy flows from hot regions to cold ones. Life is not a rebellion against entropy. It is a temporary pattern created by it. Entropy does not forbid order. It allows local order in exchange for greater disorder elsewhere. Every living system increases the universe's total entropy even as it maintains internal structure. Life rides entropy like a wave. Awareness emerges when complexity reaches a certain threshold, when systems can model their environment, when information can be stored, processed, and acted upon. Brains are not required by the universe. They are permitted by it. Nothing in physics demands consciousness, but nothing forbids it either. This neutrality is important. The universe does not favor life. It does not oppose it. It allows it where conditions align. A framework where complexity is not accidental, but unavoidable. Science has mapped how complexity arises. It has not explained why the rules allow it. This uncertainty is not a failure. It is an invitation. Equations written by human minds describe the motion of galaxies, the birth of stars, the behavior of particles. The universe is not obligated to be comprehensible, yet it is, at least partially. This suggests a deep compatibility between mind and cosmos, not because the universe was made for minds, but because minds are shaped by the same rules that shape the universe. We are not separate from cosmic complexity. We are one of its expressions. Every thought is a physical process. Every memory is encoded matter. Every idea is an arrangement of atoms following universal laws. When the universe thinks about itself through us, nothing supernatural occurs, only recursion, the universe observing itself. This perspective removes the need for cosmic purpose while preserving significance. Meaning does not need to be assigned from above. It arises from experience. A melody does not need eternal existence to matter. A moment does not need permanence to be real. The universe allows moments. As we consider why complexity exists, we also see why it is rare. Most regions of space never develop life. Most planets remain barren. Most galaxies never host observers. The universe is generous with emptiness, and yet emptiness is not failure, it is context. Without vast silence, rare patterns would not stand out. Complexity is precious not because it is destined, but because it is temporary. Being here briefly and what it means to witness the universe after traveling across distance, time, structure, and possibility, the journey quietly turns inward, not toward Earth specifically, and not toward humanity alone, but toward the idea of existing at all. In a universe this vast, this old, this indifferent, what does it mean to be here, even briefly? The universe does not pause for observers. It does not slow its expansion because something is watching. Stars continue to burn. Galaxies continue to drift. Time continues to move forward without reference to awareness. And yet, awareness exists. For a short moment in cosmic history, matter arranged itself into forms capable of perception. Not everywhere, not often, but here, now, on at least one small planet orbiting an ordinary star. This was not guaranteed. Most of the universe never becomes aware of itself. Most matter drifts, collides, heats, cools, and disperses without ever forming a memory. Consciousness is not the default outcome of physics. It is a rare side effect. That rarity gives it weight. To exist as an observer is to occupy a narrow window between conditions that are too chaotic and conditions that are too still, too early, and the universe is too hot, too violent, too simple, too late, and it is too cold, too empty, too uniform. Awareness emerges only in between. We live in that in between. This does not make us important in a cosmic sense. The universe does not revolve around observers. It does not require them, but it does make observation remarkable. For the brief duration of a human life, the universe is not just happening, it is being noticed. Every night, sky watched, every equation written, every question asked. These are not additions to the universe, they are expressions of it. Matter reflecting on its own behavior. You are not separate from the cosmos, you are observing. The atoms in your body were formed in ancient stars. The energy that powers your thoughts flows from nuclear reactions in the sun. The laws that govern galaxies govern neurons as well. When you look at the universe is looking at itself from a specific location. This reframes existence. Life is not a story the universe tells. It is a process the universe permits, and permission is enough. Nothing lasts forever, but not everything needs to. A conversation does not become meaningless because it ends. A song does not lose its value because it fades. A moment does not require permanence to matter. The universe is full of moments. Human time feels short because it is. Measured against cosmic history, civilizations flicker, languages vanish, species rise and fall. Even planets change beyond recognition. But short does not mean insignificant. A spark does not need to burn forever to produce light. Meaning exists locally. It is created by experience, memory, connection, and understanding. The universe does not assign meaning from outside. It allows meaning to emerge within. This is not a weakness of reality. It is its quiet generosity. In a universe with no observers, nothing would be wrong. In a universe with observers, something new becomes possible. Reflection, curiosity, wonder. These are not cosmic goals. They are cosmic accidents, and accidents can still matter. From the universe's perspective, nothing changes if no one is watching. From the observer's perspective, everything changes because something is. Both can be true. The future of the universe will eventually erase all traces of observers. Stars will fade. Records will vanish. Memory will dissolve into thermal equilibrium. Nothing will remember what was noticed. But erasure does not retroactively negate experience. The fact that something will be forgotten does not mean it was never real. A footprint in sand exists even if the tide removes it. A thought exists even if it is never recorded. Awareness exists even if it leaves no permanent mark. The universe does not require permanence to allow presence. This is the quiet comfort hidden in cosmic scale. Nothing demands that you matter forever. It only allows you to matter now. To witness the universe is not to conquer it or understand it fully. It is to participate briefly in its unfolding. To exist at a time when stars shine, questions can be asked, and silence has not yet won. That alone is extraordinary. How vastness softens fear, and why the universe can feel gentle after reflecting on what it means to exist briefly. Another quiet shift takes place. Fear begins to change shape. The same vastness that once felt overwhelming starts to feel spacious instead of threatening. Distance becomes cushioning rather than isolating. Silence becomes calming rather than empty. Cosmic scale alters emotion. Up close, life feels intense. Every problem feels immediate. Every loss feels final. Time presses tightly, but as perspective widens, urgency loosens its grip. The universe teaches patience without instruction. It does not rush. It does not panic. It simply unfolds. Nothing in the cosmos reacts instantly. Stars take millions of years to form. Galaxies evolve over billions. Even violent events like supernova follow long preparations. This slowness is not inefficiency, it is stability. From this scale, fear loses its sharp edges. Much of human anxiety comes from compression. Too many thoughts in too little time. Too much importance placed on fleeting moments. When everything feels central, everything feels fragile. The universe offers the opposite lesson. Nothing is central. Nothing is isolated. Everything participates in longer arcs. This does not erase pain. It reframes it. Loss still hurts. Uncertainty still exists. But cosmic perspective reminds us that instability is not personal. Change is not punishment. Impermanence is not failure. It is the default condition of reality. Stars die without tragedy. Galaxies collide without intention. Matter rearranges without regret. And yet, beauty persists through transformation. Fear often arises from the idea of being alone. Cosmic vastness seems to amplify that fear at first. But distance reveals something else. We are not alone in emptiness. We are part of it. The same laws shaping distant galaxies shape the atoms in your body. The same expansion stretching space stretches the context of your existence. You are not excluded from the universe. You are embedded within it. Vastness does not separate. It connects through consistency. The night sky can feel intimidating because it reminds us how small we are. But small does not mean unprotected. On the contrary, smallness allows shelter. It allows niches. It allows quiet corners where complexity can survive. If the universe were crowded, life would struggle. If everything were intense, nothing could stabilize. Vastness creates room for gentleness. Most of the universe is calm. Most regions are not exploding, colliding, or collapsing. They are drifting quietly. Stability is the norm. Violence is the exception. Even black holes spend most of their existence inactive. Even galaxies spend most of their time unchanged. Drama is rare compared to stillness. This realization softens fear. The universe is not waiting to destroy. It is waiting, period. Perspective also reshapes mortality. Knowing that everything changes does not cheapen life. It removes the demand for permanence. You do not need to last forever to belong to reality. You only need to occur. A wave does not fail because it returns to the ocean. A leaf does not fail because it falls. A thought does not fail because it fades. Existence is not a test. It is an event. Cosmic vastness encourages humility, but humility is not humiliation. It is relief. It releases the burden of centrality. You do not need to matter to everything. You only need to matter where you are. Meaning is local, and that is enough. Fear shrinks when the universe stops feeling like a judgment and starts feeling like a context. There is no cosmic scoreboard, no final evaluation, no universal expectation. The universe allows, not demands. In that allowance, peace becomes possible. Silence becomes space to breathe rather than emptiness to fear. Distance becomes freedom rather than loss. Time becomes depth rather than pressure. This does not make life easy. It makes it spacious. When you look at the stars without needing them to explain anything, they become companions rather than questions. They do not ask anything of you. They simply exist and invite you to do the same. This is why cosmic perspective can feel calming. It removes urgency without removing significance. It allows wonder without anxiety. It replaces fear with scale. In the end, the universe does not promise safety, but it offers context, and context is powerful. At the end of this journey, nothing dramatic happens. There is no final revelation, no hidden message uncovered, no moment where everything suddenly makes sense. Instead, a gentle permission to stop searching. The universe does not resolve itself into clarity. It simply continues. After traveling through stars, galaxies, time, and possibility, we find that the destination was never a conclusion. It was perspective, a way of seeing that allows stillness without confusion. The universe does not explain itself because it does not need to. It exists without commentary. Expansion continues. Matter drifts, energy flows. None of it waits for our understanding. And that is not a flaw. Human minds crave resolution because uncertainty feels uncomfortable. We are shaped by stories with beginnings and endings. But the universe does not follow a narrative structure. It has no obligation to provide closure. It unfolds without urgency. In that unfolding, rest becomes possible. When we stop demanding answers, silence stops feeling empty. It becomes spacious, like standing in a wide field at night, where nothing is required of you except presence. The stars do not ask to be understood. They do not need meaning assigned to them. They burn, they fade, they scatter their elements, and they move on. That is enough. We can do the same. There is a quiet relief in realizing that the universe does not judge existence. It does not reward permanence. It does not punish impermanence. It allows things to happen and then allows them to pass. Awareness is one of those things. For a brief moment, the universe arranged matter into forms capable of reflection. Not to achieve a goal, but because conditions permitted it. That permission is rare, but it is real. You are not required to justify your existence to the cosmos. The universe does not demand productivity, legacy, or explanation. It does not ask what you contributed. It does not measure your impact. It allows you to be here, and that allowance is complete. In a universe this vast, rest is not withdrawal. It is alignment, slowing down to match the cosmic pace, letting go of the need to compress meaning into urgency. Time is abundant. Silence is abundant. Space is abundant. You do not need to fill it. The end of this journey is not the end of movement. It is the end of pressure. The realization that understanding everything was never the task. Experiencing something was. A thought does not need to be eternal to be real. A moment does not need to last forever to matter. Awareness does not need permanence to exist. The universe forgets everything eventually. That does not erase the fact that something was once noticed. A ripple on water disappears, but it still shaped the surface while it existed. A sound fades, but it still moved the air. A life ends, but it still altered the arrangement of matter and memory while it unfolded. Nothing demands more than that. When the stars finally fade and the universe grows quiet beyond imagination, there will be no audience to witness it, and that is fine. The universe does not perform, it simply is. Right now, though, you are here, at a time when light still travels, when structure still exists, when thought is possible. This moment is not special because it lasts. It is special because it occurs. You do not need to solve the universe to belong within it. You already do. As this journey ends, there is nothing left to chase. No distance left to cross. No scale left to compare. Only the quiet fact of being part of something vast, patient, and indifferent in a gentle way. The universe does not hurry you. It does not ask you to keep up. It does not mind if you rest. And so, it is enough to simply stop here, to let the stars remain distant, to let questions remain open, to let silence be silence. The universe will continue whether you are watching or not. For now, you were, and that was enough.